Let us now proceed to the lesson proper. Random variables and probability distribution. You have learned in your past lessons in junior high school mathematics that an experiment or trial is any procedure or activity that can be done repeatedly under similar conditions. The set of all possible outcomes in an experiment is called the sample space. The concept of probability distribution is very important in analyzing statistical data, especially in hypothesis testing. In this lesson, you will explore and understand the random variable. Before we discuss probability distribution, it is necessary to first study the concept of random variable. Lesson 1. Random variable. It is a function that associates a real number to each element in the sample space. It is a result of chance in an event that you can measure or count. It is a numerical quantity that is assigned to the outcome of an experiment. Please be noted that we will use capital letters to represent a random variable. For us to understand better the concept of random variable, take a look on these examples. Before that, here are the steps in finding the random variable. Step 1. List the sample space or the S. Step 2. Count the number of the assigned value in each outcome and assign this number to this outcome. Step 3. Make a conclusion. Example number 1. Suppose 2 coins are tossed and we are interested to determine the number of tails that will come out. Let us use T to represent the number of tails that will come out. Determine the values of the random variable T. Solution. Step 1. List the sample space or the S. For this example, after tossing 2 coins, the sample space for these examples are HH or the head and head, HT or head and a tail, TH or tail and a head, and last is TT or tail and a tail. Step 2. Count the number of the assigned value in each outcomes and assign this number to this outcome. For the next step, we need to make a table. First column is for the outcomes or the sample space. Second column is for the number of tails as indicated on the problem that we need to determine the number of tails that will come out. Simply count the number of tails in the first column. And last, step 3, make a conclusion. We therefore conclude that the values of the random variable T or the number of tails in this experiment are 0, 1, and 2. Let us now proceed to example number 2. 2 balls are drawn in succession without replacement from an urn, containing 5 orange balls, 6 violet balls. Let B be the random variable, representing the number of violet balls. Find the values of the random variable B. Solution. Step 1. The sample space in these examples are OO or 2 orange ball, OV, an orange ball and a violet ball, VO, a violet ball and an orange ball, and last is VV or 2 violet balls. For the next step, we need to add or make a table. First column is for the outcomes. Second column is for the number of violet balls as indicated in the problem that we need to find the values of the random variable B representing the number of violet balls. Simply count the number of violet balls in the first column. Step 3. We therefore conclude that the values of the random variable B, number of violet balls, in these experiments are 0, 1, and 2.